Welcome to today's lesson on electromagnetism. We're going to explore the Biot law, which is a fundamental relationship in magnetism that describes how electric currents produce magnetic fields. Let's dive in and see how this important law works. To understand the Biot law, we need to recall the relationship between electricity and magnetism. Electric currents, which are moving electric charges, create magnetic fields around them. The Biot law gives us a mathematical way to calculate the exact magnetic field at any point in space due to a current-carrying wire. Let's examine the mathematical formulation of the Biot law. The magnetic field dB created by a small segment of current-carrying wire dl at a point P is given by this equation. Here, mu0 is the permeability of free space, a constant with a value of 4 pi times 10 to the negative 7 Tesla meters per ampere. I represents the current flowing through the wire, and dl is a small vector segment of the wire in the direction of the current. They are vector points from the current element to the point P where we're calculating the field, and r hat is the unit vector in that direction. The cross product in the formula indicates that the magnetic field at point P is perpendicular to both the current direction and the radius vector. To determine the direction, we can use the right-hand rule. If you point your right thumb in the direction of the current and curl your fingers toward the point P, your fingers will point in the direction of the magnetic field. So in our diagram, the magnetic field points out of the screen toward us, which we represent with a dot in a circle. Now, to find the total magnetic field created by the entire wire, we need to integrate this expression along the path of the wire. The magnetic field B equals the integral of dB, which gives us this integral formula. This integration can be quite challenging for complex wire shapes, but it simplifies for certain symmetric cases. Let's take a look at a classic example, the magnetic field created by a long, straight current-carrying wire. For a long, straight wire carrying current I, the magnetic field at a distance from the wire has a magnitude given by this expression. The magnetic field forms concentric circles around the wire, with the field strength decreasing as the distance from the wire increases. Another important example is the magnetic field at the center of a circular current loop. For a circular loop of radius R carrying current I, the magnetic field at the center is perpendicular to the plane of the loop with magnitude given by this formula. Notice how the field depends linearly on the current I and inversely on the radius R. A particularly useful application of the circular loop is the solenoid, which is essentially a series of current loops aligned along the same axis. For a tightly wound solenoid with n turns per unit length, the magnetic field inside the solenoid is approximately uniform and given by this formula. The field outside the solenoid is much weaker, which makes solenoids very useful in applications where we want to confine a magnetic field to a specific region. Let's quickly recap the key points about the Biot law. First, it relates electric currents to the magnetic fields they produce. Second, the magnetic field is perpendicular to both the current direction and the line connecting the current element to the field point. Third, the field strength decreases with the square of the distance from the current element. Finally, integrating the Biot law allows us to calculate the magnetic field for various current configurations, such as straight wires, circular loops, and solenoids. The Biot law is a fundamental principle in electromagnetism that has numerous practical applications, from designing electromagnets and electric motors to understanding Earth's magnetic field. By understanding how currents create magnetic fields, engineers and scientists can design more efficient electromagnetic devices for countless applications in our modern world. Thank you for watching, and I hope this explanation has helped you understand the Biot law and its significance.